Okay, so today so far so good. No one need to force to leave the meeting. Okay, so I show you the game again. So as I said that, okay, so please copy down the again or you make the screenshot. Okay, for those just join our meeting, okay, this question you have to find the internal resistance. The again given the both battery actually they are identical battery. So I need you to find the internal R. On the left, the battery was connected with a voltmeter without any conductor. So the reading of the voltmeter showing is 12 watt. And the ligand on the right hand side, right? So is the same identical battery connected with the one conductor, which is our resistor with the resistance 10 ohm. Okay, so then the voltmeter show the reading result is 8 volt. So I want to know how much is the internal resistance of battery. Okay, this one is one of the example for SPM. They will ask in this way in the paper 1. I consider one of the basic question in SPM actually. Right, I hope this answer coming in already. Not the answer yet. Right, so some answer coming in already. Internal resistance 5 ohm. Is it 5 ohm? How about the others? Okay, so now coming in all answer 5 ohm. Right. Is there anyone have the others than 5 ohm answer? Okay, if you get a 5 ohm, it's fine. So now I just want to know, is there any one of you get others than 5 ohm answer, or there's no answer for you, you don't know how to solve? Please let me know. Is there anyone unable to solve the questions? Right. So if you really don't know how to solve a question, I don't think so you will respond me lah, because everyone will know you don't know how to solve. Right. So anyway, I assume that sure there's some of you unable to solve. Now I show you the step. And anyway, for those already get the answer 5 ohm, it is for you to check whether the answer is correct 5 ohm or not. Right. So first, tell me, this 12 watt actually is what? Please respond. This 12 watt on the diagram on the left hand side actually is what? Yes, actually it's EMF. Okay, actually it's an EMF. And this what? What is this? For the 8 watt actually is what? Okay, so the V here actually is the EMF. And the 8 watt here actually is potential difference. Yes. Right, actually it's a potential difference. Because once you connected to the conductor, and the effective V that you get is a potential difference. It's just a work done across the 2 point in the circuit. It's not the total energy supplied by one coulomb of charge, right? Which is we call it EMF. Because why the potential difference is dropped is less than the EMF because of the internal resistance. The charge have to overcome the internal resistance, right? Okay, so if you still remember the formula, actually the formula we apply. Okay, for now. Okay, why my wait for a while. Okay. Right. So actually we only apply V equal to IR. V equal to IR. So since the potential difference we know here, right? Here is equal to the 8 watt. Okay, 8 watt equal to the I, because there's only out here we have, so it's I multiplied 10. Okay, so from here we know that the I will equal to the 8 over 10. Right, so 8 over 10 ampere. Remember this one you cannot left it as an answer because the fraction cannot be received, cannot be accepted as an answer. Right, so you must change it into the decimal. So 8 divided by 10 equal to how much? Right, 8 divided by 10 is equal to 0.8 ampere. So we have the current equal to 0.8 ampere. Then what are we going to do next? Okay, EMF actually is equal to the I multiply R plus R, internal R. Right, effective R of the circuit plus internal R of the circuit. Okay, then only equal to EMF. So EMF provided is a 12 watt. 12 watts, so will equal to the I 0.8 multiply 10 plus internal R. So from here, then you can slowly solve it with the 12 over 0.8, okay, minus 10, then you will get the answer equal to internal R. Right, so please get your calculator. Then we're going to do 12 divided by 0.8 equal, then after that minus 10. So you will have a 5. Okay, so that's why internal R equal to 5 ohm. Okay, so this one of the method. Okay, and the other shortcut, I think maybe some of you are trying to use using the faster express way to solve it, which is we find the work done, which is a potential difference, work done per charge across an internal resistance, which is the potential difference across internal resistance. It's the difference between the EMF minus the potential difference. So there's a way also you can solve it in faster way. But the problem is still need the current. Then you still need the current. So 12 minus 8. So potential difference across the internal resistance will be the 4 watt. Right. Okay. And then the current you can solve it with the V equal to IR as just now. So you can substitute here. Right. With the 4 equal to I multiply internal resistance. Then at the end, you will still get the same answer, 5 ohm for internal resistance. Okay, so I hope that these two different solving method able to let you double check the answer during the exam. All right. Okay. So that's all for the small division, little bit division for the 2.4 EMF and internal resistance. So now we're going to continue